Welcome to the Discover Mathematics series. In this video, we're going to look at two different ways that people can use the two-color manipulative to determine the rules for the subtraction of integers. Okay, in this video, we're going to use the two-color chip where the yellow color is positive and the red side is negative. So if we're going to build 4, and we're going to use the interpretation of -3 as take away 3, we'll just take them away, and it leaves us with 1. The next one, we have 4, and we take away 1, and we're left with 3. Here we have 4, and we take away 2, and we're left with 2. And on the fourth problem, we have 3, and we take away 1, and we're left with 2. Okay, and the question asks us, what do we notice? And what we would see is at this point that we're using the interpretation of subtraction as takeaway. Now let's look at a different type of problem where we have -3. So I'm going to have -3, so we're using the red. And I'm going to take away or subtract a -1. So here's a -1. I'm going to take it away, and that leaves me with -2. The next question, I have -7. I have -7, and I'm going to take away 2. There's -7, and I'm going to take away 2, and that leaves me with 5 negatives, or -5. The next question, I have -4, and when I take away 3 negatives, I'm left with a -1. The next question, when I have -5, and I take away 3, I have -2. And in the next question, I have -2, and when I take away -2, I'm left with nothing, or 0. And then the last question of this set, I have -4, and I'm going to take away a -1. So then I have -3. So then the question asks, what do we notice? And for this set of problems, we'll notice that if we have negatives, we take away negatives, we have fewer negatives. So it works very much like when the first group of problems, when we had positive numbers, took away some of those numbers, and we had less. So we have a negative group, we take away some of those, and we have smaller quantity. Now let's see what happens in this next group of numbers, where I have -3 minus 1. So I have -3, and I'm going to take away 1. But I don't have 1, so I can't take it away. But I'm going to remember a trick from when we added, when we had a 0 pair. And instead of getting a 0 pair and taking them away, I'm going to add in a -1 and a +1. So this right here, and I'm covering with my hand, I'm going to take it away, is a 0 pair. So I'm adding it in. Now, you see I have, here's all my integers, or my integer chips. Now I have one that I can take away. So my answer is -4. So what I did, I added a 0 pair. So by doing so, because it's 0, I'm not changing the value, but I introduced the 1 and the -1, 0, but it allowed me to have the 1 that I can remove. Okay, and we're going to look at what happens with our answers in just a moment. We're going to see if we can notice a pattern. So the next problem, I have -3, and I'm going to take away 6. I don't have 6. So how many 0 pairs do you think I'll end up adding? 6. Very good. So it's 1, 2, 3, 4, 5, and 6. So I add in all my 0 pairs. Now I have 6, a +6 that I can remove. So I'm going to take the 6 away. And now I see that I have 9 and they're negatives. The next problem I have -4, and I'm going to take away 3, a +3. I don't have +3, so I need how many 0 pairs? 3. Very good. So I'm going to have 1, 2, 3 0 pairs. Now here's my 3 that I can remove, and I'm left with 7 negatives. In question 14, I have -5, and I'm going to take away 3. So I'm going to introduce 3 0 pairs. Very good. You guessed it before I even asked it. Awesome. So here are my 3 0 pairs that I introduced. So now I can remove 3, take away 3, and I'm left with, it's my original 5 plus the 3 negatives. So I have 8 negatives. The next problem, I have -3, and I'm going to take away 2. So I'm going to introduce 2 0 pairs. There's my 2 that I can take away now, and I'm left with -5. And when we have negative 4, and I'm going to introduce a 0 pair, there's my 1, and I can take this away. Then I have negative 5. And the question asks us, what do we notice? Well, what we notice is that we had to, when we introduced a 0 pair, we ended up getting more of the negative chips. Because we're taking away a positive, so we ended up getting more negative chips. Now here, when we start with a positive 5, we're starting with a positive 5, and now I'm going to take away negative 2. I don't have any negatives. I can't take them away. So now I need to introduce some 0 pairs, and I need 2 0 pairs. So there's 1 0 pair. Here's another 0 pair. And when I take away my 2 negatives, I'm left with positive 7. In question, the next question, I have 1, positive 1, and I'm going to take away negative 2. So I need to introduce 2 0 pairs. And when I do that, I'm left with a positive 3. The next one, I have 1, and I'm going to take away negative 3. So how many 0 pairs do I need? I need 3 0 pairs. There's 3 0 pairs. Here's my negative 3 that I'm going to take away, and that leaves me with a positive 4. Question 20, I'm going to start with 6. Sorry about that. Start with 6, and then I'm going to take away negative 2. So I need to introduce 2 0 pairs. There's 1 and another 1. So now I can take away my negative 2, and I'm left with positive 8. And then the question asks, what do we notice? Because it's very similar to the ones up here, that we're getting more of what we have more of. Well, we started with the positive, and then when we are taking away the negative, since we're adding in the 0 pair, we're getting more positives. Up here, when we started with the negatives and we take away a positive, we ended up with more negatives. Now it's so that's what's happening when we do it as takeaway. Now some of you may have noticed, let's say like with this question right here, when we have 6 and we did minus the negative 2, we came up with 8. Some of you may have noticed that it's faster to just say, instead of introducing the 0 pair, what we ended up doing was the net from our 0 pair that we had here. We added 2 0 pairs, and when I took the negatives away, I ended up adding 2 positives. Think about that. I added 2 positives, and that's how I ended up with the 8. So this is actually the same as adding the opposite. Let's go back and look at number 18, where I had 1, and then I was going to take away the negative 2, and I did a 0 pair, and I did another 0 pair, and when I took them away, same thing. I have 1, and I added the opposite. Instead of the negative 2, I added a positive 2. Let's look at question number 16. If I start with negative 4, and I want to take away 1, I added in a 0 pair, and when I took away the 1, the net result is that I added a negative 1. So that's the same as if instead of subtracting, I added the opposite. So now I have negative 4 plus negative 1 gave me negative 5. So that's another way that we could see the subtraction. Instead of subtracting, we can add the opposite. What's powerful about adding the opposite is simply the fact that we don't have a new set of rules. Once we decide that instead of subtracting we add the opposite, we're adding and we have the same rules as our addition video. No new set of rules. And it allows us to have the commutative property of addition. We can change the order and it doesn't matter. That's going to be very powerful when we look at when people progress into algebra. It's really important to be able to change the order when we're adding. So that's the second approach. By adding the opposite gives us fewer rules to remember, and it gives us the ability to change the order. So that's what's important about subtracting integers. Thank you.